class 12th, I am taking the applications of Bio-Savart's law. These are widely asked in your so much competitive exams. One of the question is generally given in the NEET exam or other scientific exams of the scientific purpose. So now let us take the applications of the Bio-Savart's law. So it has mainly three applications. First is the magnetic field due to a straight long conducting wire, and second the magnetic field due to the current carrying circular coil or at its center, and second the magnetic field at the axis of the current carrying circular coil. So I am taking the first application of this one, the magnetic field due to a straight long current carrying conductor. Magnetic field due to a straight long current carrying conductor. This is our topic. So now we are having a conductor here. This is a long conductor. It carries a current I. This is this we consider a current element. This is suppose of length dl. This is the point of observation P. Then if we join to this part and this part to this one, and then we drop a perpendicular from this point P on this conducting wire or conductor. So this is the point P, so this OP, this is equal to R. This angle suppose now phi, and this angle suppose now d phi. This is the current element of length dl. So let me drop a perpendicular from this. Suppose this is now point M, this is now your point N, and we drop the perpendicular on this line so that it makes an angle of 90 degree. So this is now suppose the point Q. So consider a current element Mn of length dl. So this r is the perpendicular distance from this one, and it makes this distance is suppose now x. So let x equal to distance of point of observation P from current element, and R is the perpendicular distance. We draw a perpendicular from this P on this wire. So let OP R equal to perpendicular distance of point P from conductor. This is no conductor, this is not so much long is the conductor. And let this angle that is made by this one, this is now suppose phi 1, and this end of this conductor makes an angle with this one, and let this angle is this so much angle, this is your phi. So phi of the angle made by this and the lower end of the conductor, and phi to the angle made by this upper end of the conductor at the point P. Phi 1 equal to angle this we name this conductor to by someone. This is MN PQ. This is now suppose made by lower end of conductor at point P, and phi 2 angle made by upper end of conductor at point P. तो P पर ये लोअर एंड है, वो यहाँ पर phi 1 एंगल बनाता है, ये यहाँ से phi 2 एंगल बनाता है. तो this angle is phi 2, this angle is now phi 1, that makes with this OP, line OP. So now what we have? Draw perpendicular from N to line MP. So this perpendicular is NQ. So this angle this MQN, this is equal to 90. So this is no right angle triangle. This is no right angle triangle. According to Biot-Savart's law, this dV equal to mu naught upon 4 pi into I dl sin phi upon x square. Now we are taking from this element. Now this is the distance x, so this is now x square. This is making an angle phi, so we are writing here phi. In place of tan theta we write down this phi, and in place of r we write down this x, because this distance is from the element to the point of observation. This we take the equation number 1. So now from right angle triangle M and Q. What we have? If this angle is to be now phi, then definitely this angle will be equal to now phi. This angle is also equal to phi. So what we have, this sin phi. Sin phi. Sin phi is equal to NQ upon Mn. NQ upon Mn. Perpendicular upon hypotenuse. So this is NQ upon Mn is equal to dl. This is now your sin phi. So what we have? That this NQ is equal to dl sin phi. This is now suppose number 2. And then you can have that we have taken this Q and we have dropped the perpendicular from this so much, so this will be a circular arc. So we can have this as a circular. This P is the point and this NP and this QP, they are the radius. So we can have it to be like this one also. In triangle that we have this NQP. What we have? This D phi angle equal to arc upon radius. That we can suppose that this is the point P. This is now point P and this is now point now so much, and this is your N and this is now your point Q. This is now distance like this one. These two distances are equal, so we can have a circular arc like this. This angle is D phi that we have taken there. So this D phi is equal to NQ upon this distance Pn. So this D phi is equal to NQ into Pn is equal to x, that we have taken this to be now x1. So what we have? This NQ equal to x D phi. This is now equation number 3. So number from 2 and 3. From 2 and 3. NQ are the same one. This NQ and this NQ. So now what we have? This dl sin phi is equal to x d phi. Now then in place of this dl sin phi here in equation number 1, we will write down this x d phi. So using from equation 1, what we have, this dB is equal to mu naught upon 4 pi into I. dl sin phi is now your x d phi upon x square. So now this x will cancel by this one. So what we have, this mu naught upon 4 pi into I d phi upon x. This is equal to dV. This is now equation number 4. अब इसका जो दूसरा जो ट्रायंगल है OPN, उसमें आपको फाई दे रखा है and there is given the distance r, because we have to take the perpendicular distance from right angle triangle. OPN. What we have? This cos phi. Cos phi. This is now your base upon hypotenuse. So base is now r, and hypotenuse is x. So r upon x. This is equal to r upon x. So what we have? X equal to r upon cos phi. So now x equal to r upon cos phi. So substitute in equation 4. This dv equal to mu naught upon 4 pi into I d phi upon, this is r upon cos phi. This is not so much. So now what we are having? Mu naught upon 4 pi into I cos phi into d phi upon r. This is now your dv. This is the magnetic field at the point P due to the current element Mn. If we have to take due to whole of the conductor, then we have to integrate it. Having the limits phi 1 and phi 2. Phi 1 the angle made by the lower end, and phi 2 the angle made by the upper end. Therefore, magnetic field due to whole of the conductor this B is equal to, this is now integration minus phi 1 to phi 2 mu naught upon 4 pi I cos phi upon r. This is now your d phi. Now accept this cos phi, all are the constants, so we will take out from the integration. So this is equal to mu naught upon 4 pi into I upon r. Now cos phi, the integration of cos phi is equal to the sin phi. So this is now your sin phi with the limits minus phi 1 to phi 2. So now this B is equal to mu naught upon 4 pi into I upon r. This is now sin phi 2 minus sin minus phi 1. So this is equal to mu naught upon 4 pi into I upon r. This is now your sin phi 1 plus sin phi 2. This is the formula that can be applied for any kind of the straight conductor. And now let's suppose if the conductor is of infinite length, or infinite length long conductor, this phi 1 is equal to phi 2 and this is equal to pi by 2. जैसे कंडक्टर लॉन्ग होता चला जाएगा उससे में phi 1 और phi 2 के मान जो होंगे वो that will tend towards the pi by 2. So when this is the infinite long, then this angle phi 1 will be 90 degree and phi 2 also the 90 degree. We have taken here the minus sign in this integration, so we have not to consider that which of them will be the positive and which of them will be the negative. You have to take the positive values of phi 1 and phi 2 only. Therefore, what we have is mu naught upon 4 pi into I upon R. This is now sin pi by 2 plus sin pi by 2. This is now 1 and 1, so this is now 2 mu naught upon 4 pi I upon R. This is now 1 plus 1, so this is mu naught upon 4 pi into 2I upon R. This is now your B. So now you can see from here that this B is directly proportional to I. It means what, that we have a graph between B and I, then this will be a straight line, B proportional to I. And second thing that you look here is that this B is proportional to 1 upon R. So if we are having this now B here and this R on this side, then we will have like this B proportional to 1 upon R. So this is what the variation of this B with the current I and the distance R for an infinite long conductor. If suppose the conductor is not infinite long, this is a finite length. For conductor of finite length, then what we have, suppose this is the conductor, this is the conductor, this is suppose of length L, this is now point of observation here, then what we have, this angle and this angle, then this is equal to these are the angles, so these angles will be equal. This angle phi and this angle is also equal to phi. This is the carrying the current I and the length of this conductor is suppose L. Then definitely this length is L by 2. And this is also now L by 2. So what we have, this is now point of observation P. So at point P, here phi 1 equal to phi 2. This is now center point, that this is equal to now phi. Therefore, B equal to mu naught upon 4 pi into I upon R sin phi plus sin phi. So this is equal to mu naught upon 4 pi into 2I sin phi upon R. R is the distance OP. OP is equal to R. OP. This is not distance R. So now we can have that this is equal to mu naught upon upon 4 pi into 2I upon r, and this sin phi will be equal to how much? Perpendicular upon hypotenuse, then this distance, this so much, this is your r square plus L upon 2 whole square is so much. Similarly this one, so this is equal to L upon 2 upon square root of r square plus L square upon 4. This is the value of this sin phi, so this is equal to so much. So now if you see that this 2 and 2 will cancel, then this will be not 2IL upon so much, that you can write to this one. This is the main formula for this conductor. If suppose we are having the magnetic field at one end of the conductor, at one of the end of conductor. तो one of the end of the conductor में क्या है, मतलब इसका what do we mean to this one? For one end of the conductor means that this is the conductor, this is appearing the current I, and the point is here. This is no point P. This is just at distance R from here. Then if we join to this one, this, then this angle is phi. So what we have, this is known as L, then this distance is equal to square root of r square plus L square. So now what we have here, this phi 1 equal to 0 and phi 2 is equal to 5. So this B equal to mu naught upon 4 pi into I upon R. This is now sin 0 plus sin phi. So we have this mu naught upon 4 pi into I upon R sin phi. This is equal to B. So this B is equal to mu naught upon 4 pi into I upon R sin phi. This perpendicular upon hypotenuse. So this is L upon square root of R square plus L square. This is for sin phi. This is now so much difficult. So you can have so many applications of this long straight conductor. You may be given suppose you are given a triangular arrangement of the conductor, or this is now rectangular, or this is now suppose in the form of the square, then current is passing through that. You can find the magnetic field at the center of all these shapes by means of this formula. So this is about the magnetic field due to a very long straight conductor. So thank you very much.